Alright guys, what we want to move on to is understanding scales. And this should not be novel to you because you would have done that before you started doing quadratic graphs in grade 10, obviously. So understanding scales is very important before we start attempting to draw any of the statistical graphs, the technical ones like the cumulative frequency curve or the histogram or the frequency polygon. Those three are the most technical graphs that you need to draw. The others that we're going to learn after, very easy, but it's important that we understand scales to get those three particular graphs drawn. So we're going to go straight into that. So here we have some scales shown on a sheet of paper, and the first thing we want to zoom in is on that one. Now obviously when you're talking about graphs, you know you have a horizontal x-axis and you have a vertical y-axis. So whether it is like this or like this, it applies to both axes in terms of how you number the scales. All right. So what we want to do, looking at each individual scale, is try to figure out how we number based on the numbers that are here already, how we fill in these intermediate values, and then determine what scale exactly it is. Now on the graph sheet, you all should be familiar with the graph sheet already, meaning that you know the graph sheet is separated by some lines that are 1 centimeter apart. So on the graph sheet, the lines that are lines here would be 1 centimeter apart. I'm just amplifying the graph sheet so you can see it. And you always have 4 lines in between the major lines, right? So you always have 4 little lines in between the major line, always. So irrespective of the scale, the same thing is going to exist. 1 centimeter apart and 4 lines in between. 1 centimeter apart and always 4 lines in between. And again, this shows clearly the horizontal axis, but if it turns this way, it's the same concept for the y-axis. All right, so let's focus on this one first. Now the question is, if you have 0 here, 1 here, and 2 here, and 4 strokes equidistant apart between the major values, how do you count? So that's the important thing that we need to get at. So my question is this: if this is 0 and this is 1, how do you count from 0 using these 4 strokes to get to 1? Now that would be very, very simple. So first of all, if I turn it this way, right, and you're going up from 0 to 1, obviously it's 0.2, 0.4, 0.6, 0.81. Same thing here, right? 0.2, 0.4, 0.6, and 0.8, and then 1. So this would be, let me do it this way so it's kind of easier to read. So this would be 0.2, 0.4, 0.6, 0.8. It must be the same values or amount, right? The difference must be the same going up, right? To get to the 1, it must make sense. So you couldn't have 0.1, 0.2, 0.3, 0.4, and then suddenly get to 1, because here will be 0.5. So you have to go by a certain amount that makes sense to get to the value. And obviously this would be 1.2, 1.4, 1.6, 1.8, and then 2. So really and truly, when you look at it, this is always 1 centimeter apart on your graph sheet, always 1 centimeter apart. So the big question is, what would this scale be? So in this particular case here, the scale is simply for every 1 centimeter, you're going up by 1 unit. So for every 1 centimeter, you're going up by 1 unit. So 1 centimeter means you're going up by 1 unit, right? So for every 1 centimeter, you're going up by 1 unit. And again, this is the horizontal axis, but it could have been turned this way to represent the vertical axis as well. Same thing. All right. Now let's look at this one here. This is 1 centimeter again. That's another centimeter. But what is the scale? How much are we actually going up by? And let us try to figure out the scale for this one. Let's try to figure out the scale for this one. So it clearly means here, this is 1 centimeter, and that's another centimeter. That means for every 2 centimeter, we're going up by 1 unit. So for every 2 centimeter, we're going up by 1 unit. So if this is 0, this is 1, then obviously inside here must be the must be the midpoint, which is 0.5. So 0, 1, this must be 0.5, which is the middle of 0 and 1. So the question is now, if this is 0 and 0.1, which is totally different from this scenario where you had 0 here and 1 here. So the scale is different because for every 2 centimeters, you're going up by 1 unit. So if this is 0 and this is 0.5, how do you count in between? That's very simple. So if this is 0, this is 0.1, 0.2, 0.3, 0.4. There's no way you can count the same way like this one because you have two different values here and here. This is 0.5, this is 1. So you have to count differently between the 0 and the main numbers. And of course, 0.6, 0.7, 0.8, 0.9, and after 0.9 comes 1. So this is a totally different scale used here than the scale for here. So for this one, again, we're trying to figure out what the scale is. So if you notice here now, again, 1 centimeter, 1 centimeter, 1 centimeter. So in this particular case, for every 1 centimeter, you're going up by 2 units. So for every 1 centimeter, you're going up by 2 units, or 1 centimeter represents 2 units. 2 centimeter represent 1 unit, 1 centimeter represent 1 unit. So come back here. So if this is 0 and this is 2, how would you count between these bars here? All right, so I'm going to call this figure 3 because I'm going to be asking you to tell me how to count between these points. So if this is 0, what would this be? What would this be? What would this be? What would this be? All right, so this is 0 and you have 1, 2, 3, 4, 5. All right, so 5 steps from 0 to get to 2. 1, 2, 3, 4, 5. What exactly would be the values that we're counting up by? So I'm going to call this one figure 3, and I'm going to ask you guys to quickly draw this on a piece of paper and give me that as soon as this video ends. All right, so this one is yours. All right, so I'm going to move this out of the way now. All right, let's look at this one. All right, well, this one here, this is 0 and this is 5. Again, this is 1 centimeter. Remember, this is always 1 centimeter, always 1 centimeter. The major lines, and they always have 4 strokes in between. That's 1 centimeter. My question is this: what's the scale for this one? This is saying for every 1 centimeter, we're going up by 5 units. So the scale for this one is for every 1 centimeter, we're going up by 5 units, or 1 centimeter represents 5 units. So if this is 0 and this is 5, then clearly this is 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. Okay, very, very simple. And I'm going to call this figure 5, right? And clearly here this is 0 and this is 5. Now the question is, what is the scale for this one? And you're going to be telling me that as well. So you're going to draw that on paper and send that to me. And this is 0, this is 5. I'm going to help you a little bit. This must be 2.5. The midpoint between 0 and 5 must be 2.5. So you're going to tell me now what these values are, right, to get to the 2.5. So there are 2 things that you're going to do for me as soon as this video ends. You're going to draw this here for figure 3, draw this on your paper, and number in between them to get to 2. Tell me how you're going to number to get to 2, and there as well to get to 4. And for figure 5, you're going to do the same thing. Tell me the scale as well. I gave you the scale for figure 3, right? For every 1 centimeter, you're going to buy 2 units. So you're going to tell me the scale for figure 5 as well as fill in those missing numbers. So those 2 you're going to do for me. As soon as the video ends, you're doing figure 3 information. In this particular case, just fill in the numbers. And for figure 5, tell me the scale as well as fill in the numbers. And let's see if you guys are right about that. So I hope you guys found this video insightful, and I'll see you in the next video.